All right, so we've made it to the very last section that we need to do this semester. 6.8 is on the area of circles and sectors, which we have not talked about yet. So the area of a circle is actually the number of square units it takes to fill a circle. You may even remember when you first learned about area back in grade school, you probably first learned about area by dividing shapes up into squares and then counting the squares. So whenever we get area, like say the area is equal to 20 square inches or 35 square centimeters, that's literally saying that that's the number of squares that will fit inside of that thing. So we're finding the area of a circle, we're asking how many squares will fit inside of that circle. So let's talk about how we get the formula for the area of a circle. So the first thing we do to derive the formula for the area of a circle is I take my circle and I divide it up into sectors. In fact, if you actually take a circle right now, cut it out, and then cut out each of these sectors like you had a piece of pizza, and you cut out each of those pieces, and then you line them up like this, you get something that resembles a parallelogram. And we know the area of a parallelogram is base times height. We'll look at the base and the height of this figure. The height, it says, is r. Look back at the actual circle before we moved it. There's the height of the circle, the height of the parallelogram we're looking at, which is also the radius of our circle. The base of our parallelogram, the base of our parallelogram here, it says, is pi r, because the base of the parallelogram covers 1, 2, 3, 4 arcs out of the 8 sectors. 1, 2, 3, 4 arcs out of the 8 sectors covers half of our circumference, half of our outer edge. And since the circumference of a circle is 2 pi r, half of that is just pi r. So if the area of a parallelogram is base times height, then the area of this parallelogram is pi r times r, or the area of this circle is pi r squared. So in this formula, A stands for area of a circle. R again stands for radius. And again, that symbol is pi, which Apex wants us to round to 3.14 anytime that we use it in the equations for this. Let's go ahead and use this formula. So in this first one, we can see the radius is 4 units long. So r squared then, r times r would be 16. So pi r squared is pi times 16, which is 50.24. And I again just use my calculator to get that. And I don't need to round here because it's already rounded to the nearest hundredth. All right, I'm going to skip this part here. It's in Apex if you want to look through it, but it's not super relevant to what we're doing. It's just kind of to get you to relate this to some real life things. We're going to stick to what's super important here since I'm kind of recording this. So the first thing I want to go right here at part 9 is the term sector. A sector is a region inside a circle that's bounded by the central angle and the intercepted arc. So in other words, if I have this circle here, then a sector is like going to be like a slice of this circle. Like a slice of pizza or a piece of pie. So a whole circle is like a whole round pizza, where a sector of a circle is like a slice of pizza. So if I'm looking for the area of a sector, I'm looking for the area in one slice of that circle. Before we get to the actual equation, let's look at this the same way we looked at arcs. If this sector covers half of the circle, then wouldn't it be half of the circle's area? Well, it tells you down here that the area of this particular circle is 10 square inches. So since the sector covers half the circle, to find the area of the sector, we just divide that 10 by 2, or multiply it by 1/2 to get 5. On this one over here, we have a similar thing happening, but now our sector covers 1/4 of the circle. So if the whole circle is 10 square inches, then 1/4 of that would be 2.5. 10 divided by 4, or 10 times 1/4, is 2.5. Okay, so again, just like last time, they're not really going to tell you how much of a circle is covered. Usually, instead of giving you like this sector covers half the circle, they'll instead tell you this central angle is 180 degrees. So if they tell you it's 180 degrees, how do you know how much of the circle it covers? Well, 180 out of 360 is 1/2. So again, we can tell that it covers half the circle. Same thing here. We did this in the last section. Instead of telling you that the sector covers 1/4 of the circle, they usually just tell you that the central angle is 90 degrees. And we know 90 is 1/4 of 360 because 90 over 360 simplifies to 1/4. So again, I can do that with any angle measure. If I was looking at this sector and you were told that the central angle is 30 degrees, then I would say, okay, well, 30 out of 360 is, let's see, that's 12, 1 over 12. So that would be 1/12 of the full circle. So I'd find the area of the whole circle and divide it by 12 to get just that one slice. And that's exactly what the sector area formula is. This part here is this measure of the central angle in degrees over 360, which gives us the fraction that that sector covers in that circle. And then the other part of this formula, pi r squared, is the area of the circle. So altogether, this gives us the area of a fraction of a whole circle. Let's go ahead and use it a few times. Okay, in this one, we're trying to find the area of the shaded sector. I can see the central angle for this shaded sector is 300 degrees. And the radius of my circle is 8. So they start by finding the area of the whole circle. Pi r squared, where r is 8, is 200.96. That's 8 squared, and then multiplied by 3.14. Then I need to find the fraction of the circle. My central angle again was 300, so that's 300 over 360, which simplifies to 5/6. One note here, if you have a trouble simplifying your fractions, if I just use this form of my fraction in my equation, I'll still get the correct answer. So for example, the next part here they say is to take the area, 200.96, and multiply it by 5/6. If I were to take 200.96 and multiply it by 300 over 360, you'll get the exact same answer. And as a reminder, when you're multiplying a whole number by a fraction, you multiply by the top and then divide by the bottom. So if I was going to do this in my calculator, I would do 200.96 times 300 and then divided by 360. Or for 5/6, I would do 200.96 times 5, which is on the top, and then divided by 6, the denominator. Either way, you get an answer of 167.466666 repeating, which rounded to the nearest hundredth is 167.47. 167.47 square units. Let's try a few more examples. Okay, and these sectors, they don't give us the whole circle, but that's fine, we don't need it. All we need is the radius and the measure of the central angle. The area of a sector is always equal to the measure of the central angle over 360 times the area of that circle, pi r squared. And in this case, r is 10. So I do 120 divided by 360, I can leave it like that, or I can simplify the fraction. I happen to know 12 over 36 is 1/3. And then I do pi times 10 squared. Make sure you square first and then multiply by pi. You should get 314 exactly. And then I take 314 and multiply it by 1/3, which is the same thing as dividing by 3. So I can do 314 divided by 3. And I get 104.6666 repeating, so I'll round that to 67 square units. Okay, let's look at the next sector. In this case, our central angle is 60 degrees. And our radius is 13. So again, I can leave my fraction as 60 with 60 and I'll get the correct answer, but I happen to know that 6 and 360 simplifies to 1 over 6. And let's just see what the area is. 13 squared times pi. Make sure you square before you multiply by pi. So that ends up being 169 times 3.14, which is 530.66. That's the area of the whole circle. So 1/6 of that, I can multiply that by 1/6 or just divide it by 6, which gives me 88.44 square units.